All right, guys, welcome back. I'm now going to go over and show you how to use the product and quotient rule, which will make your differentiating lives a lot easier. So first let me write down what the rule is for the product rule. So what this says is if you want to take the derivative with respect to x of the product of two functions, let's have f of x times g of x be our two functions. This says that this will be equal to the derivative of f of x, so f prime of x, times g of x plus f of x times g prime of x. You see? So it's pretty simple. Take the derivative of the first one, multiply it by the second function, then add it to the first function, multiply by the derivative of the second one. It doesn't actually matter the order. So let's just go over an example, beginning with I can barely see. Okay, there we go. 3x minus 2x cubed. Let's go 3x. Minus 2x cubed times 5 plus 4x. Oops. Times 5 plus 4x. So let's have that be a 2 instead. So this will be our f of x. This is our f of x. Let's just leave it as f. This is our f, and then this is our g. So we have f times g. So if we want to find h prime of x, oh man, I gotta get down low. This is a short whiteboard. What I do is take the derivative of this. So this will be 3 minus 4x. Leave this guy the same. Okay, guys. To leave that as 5 plus 4x. Then plus. Now I'll leave this the same. 3x minus 2x squared times the derivative of 5 plus 4x, which is just going to be 4. And then I just do some math and simplify this using the math from, the past. Man, you gotta do a lot of work here. 15 plus 12x minus 20x minus 16x squared. Plus 12x minus 8x squared. Man, be down low. Hey guys. 16x squared minus negative 24x squared. 12x minus 8x, or 12x minus 20x plus 12x. 20, so 4x plus 15. There we go. Now, you can very well expand this first and then take the derivatives of each individual term by using the power rule. So sometimes maybe that's easier or more, maybe it's faster, but same thing. All right, let's look at another example. Let's go to 3x squared times the sine of x. So for b, we have 3x squared times the sine of x. And again, use parentheses as much as you can. They'll be your best friends. All right. So we have our f of x here. That's our f. We got our g here. Two functions. So y prime will be f prime, or 6x, times the sine of x, keeping that the same, and add that to, now we leave f of x the same, so leave that as 3x squared. Then take the derivative of the sine of x, which would be the cosine of x. And then we can combine these if there's something to combine. There's not really much to combine, because maybe you can just factor out a 3x, which will give you 3x times 2 sine of x plus x cosine of x. There you go. All right, let's keep this going. Hey guys, say hi to Odie. Hello. Let's go with another trig one where we have 2x cosine of x minus 2 sine of x. I'm gonna erase that. My fancy eraser. So 2x cosine of x minus 2 sine of x. All right, so all this is combining the fact that you're adding or that you're subtracting two functions, but this ain't an issue. So this will be like our f of x here. This is our g. And this is just something else entirely. So if we're taking the derivative of this, we'll have the derivative of 2x, which is, let me just get down here, down low. The derivative of f, which is 2, times, leave g of x as is. Now added to f, leaving f of x as is, so 2x times the derivative of the cosine of x, so the negative sine of x. Now this, you just then, from here, you just take the derivative on its own. Subtracting 2 times the derivative of the times the derivative of sine of x, which is the cosine of x. And then you can just combine these. Oh, these cancel. And you're left with y prime equals negative 2x sine of x. All right. Let me get some water. Okay, here I am. Okay, now let's look at the quotient rule. The quotient rule is a very annoying rule. I don't really even like it, but it is useful sometimes. But it's a necessary evil, and it is going to be when you want to take the derivative of a quotient. Let's say you have f of x over g of x. This will be equal to the denominator function, or g of x squared in the denominator, on top. This is where you want to memorize, or there's different ways of how textbooks will write this. I like to just have this derivative come first. I'll go f prime of x times g of x minus f of x times g of x, or times g prime of x. For some reason, it's just easier for me to remember that. because like everything kind of stays in place. It's like fog minus fog. So in other words, I would just remember like f prime times g minus f, times g all over g squared. So it's like fog minus fog, but it's not a composite function. Hydro flask is blocking the view. But just find a way to remember it. It's just like a necessary evil. I don't even necessarily believe they should make you memorize these on tests, but they do. Okay, so let's just practice using it with this example. We have y equals 5x minus 2 over x squared plus 1. Okay, so here this is our g. Up here is our f. Yeah? So if we want to find y prime, we're going to have this squared in the bottom, x squared plus 1 squared. I don't know about that too. Come on. Here, take the derivative of the top, f prime of x. So the derivative of the derivative of 5x minus 2, which will just be 5, multiplied by the bottom, multiplied by x squared plus 1. Let me actually write this. G's kind of making this weird. Let me just make the bottom like that. I think you get the idea. Hopefully, hopefully. Then from here we subtract the top, keep the top function, 5x minus 2. And now we multiply by the derivative of the bottom, which is the derivative of this. The derivative of x squared plus 1 is just 2x. And then we just got to clean this up. I'm going to move this up here so I don't have to bend down so low. So we got 5x, we got y prime equals 5x squared plus 5 minus both of these multiplied by that, minus 10x squared, minus 4x. And now we just do the algebra stuff. 5x squared minus 10x squared minus 5x squared, bang, bang, 5 minus 4, so minus 4x plus 5 all over x squared plus 1 squared. Here we go. That's our quotient rule example. Wasn't that fun? Not really, but it's just something you got to do when you have, it's just a way to take derivatives when you have like a fraction with like, complicated polynomials. But let me go over one more thing. Let's see. All right, so something to point out. Let's say like you have something like this. Let's say you have a derivative or a function y equals -3 times 3x minus 2x squared all over 7x. If you got something like this, don't just straight up jump to the quotient rule, because if you work this out, you'll get that y is -9x minus or plus 6x squared all over 7x. Oh. And then you can actually cancel out x Let me erase this guy. Because then you can cancel out x from each term, and you'll get y is negative 9 plus 6x over 7. Then it's just, then if you want to take, it's just y equals 1/7 times negative 9 plus 6x, which is just taking the derivative of this. You're just going to take, it's just 1/7 times the derivative of this. So y prime would just be 1/7 times the derivative in here, which is just 6. So your answer is actually just going to be 6/7. So don't make this very complicated by using the quotient rule just because you see like some stuff on top and some stuff in the bottom of a fraction, because you're going to make your life a lot more painful than it needs to be. So be careful about that, because I noticed this on tests. There's always like a couple students that will work these out in a complicated way, so don't be that student. Yeah, all right, so I hope that helps. I'm going to go over the next using the chain rule, so keep a lookout for that. And of course, feedback is always helpful, so let me know what you think, and subscribe, and I'll see you guys later.